Before we start anything, let's think about how we can solve this question. We know both cos x and sin x terms in terms of tan x over 2. Cos x value we can write as 1 minus tan squared x over 2 over 1 plus tan squared x over 2. And sin x value we can write as 2 tan x over 2 over 1 plus tan squared x over 2. So, if we substitute u equals tan x over 2, then we can express cos x and sin x in terms of u. After that, we can find dx value in terms of du. And finally, we can change the upper limit and lower limit corresponding to u variable. Then we can simplify this integral. Clear? Let's jump into the question. Substitute u equals tan x over 2. Differentiation with respect to x. Differentiation of the u value we can write as du over dx. Differentiation of the tan x over 2 value we can write as sec squared x over 2. Differentiation of the x over 2 value we can write as half. Then we can cross multiply denominator value dx. After that we can subject dx value as 2 du over sec squared x over 2. We know sec squared x over 2 means 1 plus tan squared x over 2 according to basic trigonometry equation. Instead of tan x over 2 value, we can substitute u. Then we can write dx equals 2 du over 1 plus u squared. Now we need to change lower limit and upper limit according to u variable. When x equals 0, u equals tan 0 over 2. Tan 0 over 2 value equals tan 0. Tan 0 equals 0. Therefore, u equals 0. When x equals pi over 2, u equals tan pi over 2 over 2. Tan pi over 2 over 2 value equals tan pi over 4. Tan pi over 4 means tan 45 degree. Tan 45 degree equals 1. Therefore, u equals 1. Cos x value we can write as 1 minus tan squared x over 2 over 1 plus tan squared x over 2. Instead of tan x over 2 value, we can substitute u. Then we can write cos x value as 1 minus u squared over 1 plus u squared. Sin x value we can write as 2 tan x over 2 over 1 plus tan squared x over 2 using tan x over 2 terms. We know tan x over 2 means u. Therefore, we can write sin x value as 2u over 1 plus u squared. Let's move to integration part. Now, lower limit 0, upper limit 1. Instead of cos x value, we can write 1 minus u squared over 1 plus u squared. Instead of sin x value, we can write 2u over 1 plus u squared. Instead of dx value, we can write 2 du over 1 plus u squared. Then we can get a common denominator in the denominator. It is 1 plus u squared. Denominator of the denominator value we can write as numerator. After that we can cancel out numerator value 1 plus u squared and the denominator value 1 plus u squared. Now we can remove the brackets and simplify the denominator as u squared plus 6u plus 9. Numerator value 2 is a constant, so we can bring this 2 value outside of the integral. Denominator value we can write as u squared plus 2 times u times 3 plus 3 squared. This quadratic polynomial just like a squared plus 2ab plus b squared. A squared plus 2ab plus b squared equals a plus b perfect squared. So in here u squared plus 2 times u times 3 plus 3 squared value we can write as u plus 3 perfect squared. We can write the denominator value u plus 3 perfect squared as u plus 3 to the power of minus 2 in the numerator. We know integral ax plus b to the power of n equals ax plus b to the power of n plus 1 over a times n plus 1. So in here, integral u plus 3 to the power of minus 2 value we can write as u plus 3 to the power of minus 1 over minus 1 using this equation. Denominator value minus 1 is a constant. So we can write 1 over minus 1 value outside of the bracket. Numerator value u plus 3 to the power of minus 1 equals 1 over u plus 3 to the power of 1. Finally, we need to substitute upper limit and lower limit for 1 over u plus 3 value. First one, upper limit 1 minus second one, lower limit 0. Then we have 1 over 4 minus 1 over 3. Then we can get a common denominator 12. Numerator value 3 minus 4. 3 minus 4 equals minus 1. After that we can cancel out numerator value 2 and the denominator value 12. Minus 1 into minus 1 plus 1. So we can get the final answer as 1 over 6.